Hello and welcome to today's lesson on reflection in the context of mirrors. In today's lesson, we will learn how to draw ray diagrams for reflection in mirrors. Then we will identify the properties of virtual images, including lateral inversion. So far, we have familiarized ourselves with the concept of reflection and practiced constructing ray diagrams to show how light reflects off surfaces. Building on this foundation, we can now deepen our understanding by exploring how these principles apply specifically to mirrors. Let's get started. So how does light behave when it hits a mirror? Well, you will recall it follows two simple yet crucial rules known as the laws of reflection. First, the angle of incidence is equal to the angle of reflection. Secondly, both the incident and reflected rays lie in the same plane as the normal, which is a perpendicular line to the surface at the point of reflection. By following these laws, we can accurately predict how light will reflect from smooth surfaces like mirrors. To illustrate this clearly, let's construct a ray diagram together. Step 1. Draw the mirror as a straight horizontal line across your paper. This will represent the reflective surface. The second step is to represent the object. Draw a dot to represent your object. The dot will be our reference point for drawing the rays. Moving on to step 3. Draw two rays from the top of the object, heading toward the mirror. One ray should head directly toward the mirror at an angle, for example, diagonally downward. The second ray should head toward the mirror at a steeper angle. These are your incident rays. Each ray will reflect off the mirror at an angle that follows the law of reflection, which we'll address next. Next, at the point where each incident ray meets the mirror, draw a normal line at a 90-degree angle to the surface. This will help us measure the angles of reflection. Finally, step 5. Using the law of reflection, draw the reflected rays, ensuring the angle of reflection matches the angle of incidence. When you extend the reflected rays backward with dashed lines, something interesting happens. They appear to meet behind the mirror. This point is where you see the object's reflection is referred to as the virtual image. A virtual image isn't real. The light rays don't actually meet there, but it looks as if they come from behind a mirror. Unlike real images, virtual images cannot be projected onto a screen because the light rays do not actually converge at the image's location. Instead, virtual images are perceived by the eye as if they exist behind the mirror. The light rays appear to come from this virtual point, but they never physically meet there. In the case of a mirror, your brain interprets the light as originating from behind the reflective surface, which is why the image seems to exist but can't be captured on a screen. The virtual image appears to be the same size and orientation as the actual object, but is reversed left to right. This reversal is known as lateral inversion. Notice how the red ray appears on the right of the object, but is flipped to the left in the virtual image. This is why when you raise your right hand in a mirror, your reflection appears to raise its left hand. In today's lesson, we delved into the concept of reflection as it applies to mirrors. We used our understanding of the law of reflection to draw ray diagrams, helping us visualize light travels and reflects off a mirror. This included drawing the mirror as a straight line, representing the object, and constructing incident and reflected rays. We saw how light rays reflect off the surface, creating a virtual image behind the mirror that appears reversed and in the same size as the object. Understanding this process will help us as we continue to delve deeper into the properties of light and how it interacts with different surfaces, especially mirrors in various contexts. Watch the rest of the GCSE physics course at Sophos Education.